A particle of mass 0.5 kilograms moves under the action of a single constant force, which is a two-dimensional vector. Find the acceleration. So I'm going to use force equals mass times acceleration, and I'm going to do this in column vector format. So F equals ma, force is 2i, 2 in the I direction, 3 in the j direction, mass is 0.5, and acceleration we don't know, so I'm going to call that just P and Q. So now I can see from that for the I direction, 2 equals 0.5p, so in the I direction P is equal to 4, and in the j direction 3 equals 0.5q, so q is equal to 6. So the vector for acceleration is 4i plus 6j. For part B, at time t seconds, p has velocity v. When t equals 0, v equals 4i. Find the speed when t equals 3. So this looks like a suvat. So let's write down the conditions: S, U, V, A, and T. I know that initial velocity given here is 4i. Final velocity, I don't know. I'm trying to find the speed, so that's related to velocity. Pi plus qj, because we don't know what it is. Acceleration is worked out in part 1, which was 4i plus 6j, and time we're given here is equal to 3. So using v equals u plus at, and I'm going to write these in column vector format. So v pq equals u, so that's 4i and 0j, plus a, which is 6 multiplied by t, which is 3. So now making an equation for the I direction and the j direction. P equals 4 plus 12. So P equals 4 plus 12, which is 16. And Q equals 0 plus 18. So Q equals 18. So that means that the velocity is equal to 16i plus 18j. Now actually I'm asked for the speed here, and speed is a scalar. It's actually the magnitude of v. So the magnitude of this vector using Pythagoras is the square root of 16 squared plus 18 squared, which is 24.1 meters per second. For part C, find that given that p is moving parallel to the vector 2i plus j at time t, find the value of t. If two particles are moving parallel, their vectors their velocities are parallel. So one will be a scalar multiple of the other. So the velocity of p will be a scalar multiple of 2i plus j. So let's just write that to start with. So if we use p and q again, so the velocity of particle p will be pq, and that's going to be a scalar multiple, say k, of 2i plus 1j. So what I need to do is find that velocity of p. Using, again, suvat, I have S, U, V, A, and T. Initial velocity is 4i up here. Final velocity, I don't know, that's P I and qj. Acceleration I found over here in part A, so that's 4I plus 6j. And time, we don't know, that's t. So I'm going to, again, equate coefficients of I and j. So for, before I do that, I need to make the equations. So I've got u, v, a and t, so using v equals u plus a t. I have pq, that I don't know yet, equals u, which is 4 in the I direction and 0 in the j direction, plus a, which is 4, 6, multiplied by time. So now I can equate coefficients. So I, p equals 4 plus 4t, and in the j direction, q equals 6t. So I have both parts of the vector. So the velocity of this vector now will be 4, we can actually just write that as a column vector like that, 4 plus 4ti, 6tj. So I've said here that that was a scalar multiple of this vector here, so I'm going to make an equation for that. So 4 plus 4t over 6t, the velocity of particle p, is equal to k multiplied by the vector 2, 1. So making an equation for each of these rows, 4 plus 4t equals 2k, and 6t equals k. Now, if I divide this vector through here by 2, I will have 2 plus 2t equals k, so I'd rather use that one. Both of these left-hand sides are equal to k, so they're equal to each other. So 6t equals 2t plus 2, and when we rearrange that, we get t equal to a half. So marks-wise for this, there's a method mark here for clear use of f equals ma, even if there are some sign errors. There's an accuracy mark then for the final vector. Then for part B, there's a method mark for clear use of v equals u plus at, so down here, and an accuracy mark for finding the vector, and then a method mark for clear use of Pythagoras to find the magnitude of the vector, and an accuracy mark for finding the final answer. Remember that with the method marks, 1 or 2 errors are allowed as long as it's clear that you have attempted to use the correct equation. For part C, there's a method mark for equating, for making an equation v equals u plus at. Then there's another method mark for finding simultaneous equations and equating them to each other here. And then there's an accuracy mark for the final answer correct.